So we are going to talk about a few things here that we see daily, okay? So we're talking about population and sample to start, okay? Population is a set of entire set of subjects. So for example, a population would be all Ludlow students, okay? Another population would be all high school students, all adults, okay? So that's the population. It's the big picture. The sample is a part of the population. So if our population was all Ludlow students, a sample could be the junior class. A sample could be this class. A sample could be students aged 15, okay, that sort of thing. It's a part of the entire population. So one thing to keep in mind is the bigger the sample and the more random, it's better for your study, okay? It reduces some of the errors if we have a larger sample, okay? It's very, very difficult to gather information about the whole entire population, okay? The U.S. as a whole, or the world as a whole, runs a census, okay? A census is run every 10 years because it's very expensive. They try to reach everybody in, let's say, the U.S., okay, to gather some information on income, where you live. They do mailings, they do phone calls, they do even people stopping by to answer some questions, okay, to gather an updated statistics on the population, okay? There's a number of questions that they ask, okay? But there's issues with that, okay? Sometimes it's not always accurate. They don't reach every person that they need to, okay? Some people might lie. Those are some errors that occur, or not answer, or hang up, which happens a lot, right? People call for a survey, you're like, oh, okay, bye, click, right? So those sort of things happen. So that's why we sample to make an inference about the population. All right, so we have two examples here, okay? The probability and statistics class is doing a study on how many hours students at Ludlow spend on TikTok during one day, okay? They poll one class of each grade and collect their data. So what is the big picture? What is the population? Camilla? Good. Students at Ludlow. Okay, what is the sample? Hannah? Good. Good. Okay, so again, population, big picture, sample, the smallest picture. All right, a piece of that puzzle. Your wrestling coach wants to sign up his team for a tournament over the first weekend in March. He polls the seniors to see if they're available before asking the whole team. Okay, what is the population? Is it fun? Yep. Okay, what is the sample? Yeah? Yeah? Okay, good. Very straightforward. So we figured out who we are collecting data on. Now we want to figure out what we want to learn from that data. Okay, so that's what leads us to parameter and statistic. Okay, parameter is a population summary. So parameter and population go hand in hand. Okay, statistic, which we see a lot of, goes with sample. So some keywords we might see is gross movie tickets, the mean or the average, percent, proportion. Okay, those are some keywords we are going to see. Now, one thing when we figure out the parameter and the statistic, the wording is going to be identical. One might have a numerical value, one may not. Okay, but the wording will be exactly the same, just like with population and sample. It's going to be very similar. All right, so Again, it's often hard to measure an entire population, so therefore it's very, very hard to get a numerical value, a parameter. In some cases, just to start, we're going to show you what it looks like when you're given a parameter, but most of the time it's unknown, okay? So if the parameter states percent of average time, the statistic will be the actual percent or the average, okay? So the keywords will be exactly the same. So an example from a reliable source, Snapple.com, okay? Clearly the caps over there. 13% of U.S. adults are left-handed. At a school's admin conference, 16% of students of adults attending were left-handed. So, population, big picture, all adults, okay? Sample is adults at the school admin conference, okay? So, a piece of the puzzle of the big picture. Parameter, 13% of adults in the U.S. are left-handed. This was actually given, okay? The parameter was actually given because it's representing adults in the U.S., okay? The statistic was also given. 16% of the adults attending the conference were left-handed. So if you notice, you have some keywords here. Adults, adults, same. Mentioned in population and sample. Then parameter, you have both percentages, but one's about the total population and one's about the sample, okay? So you're going to see very similarities. Sometimes this is very easy, but people make it very complicated in terms of figuring out what the parameter might be. And we're going to see what it is right now when the parameter is unknown, okay? So a random sample of 300 Ludlow juniors were asked when they go to bed during the school week. 85% of these students went to bed after 11. Okay, so first and foremost, what is the population? Stefan? All Ludlow juniors. God bless you. What is the sample? Kennedy? Good. 300 Ludlow juniors. So again, population sample wording is roughly the same. One says all and one is an actual number. Okay? Now, 85% of these students went to bed after 11. So what would that be? Parameter or statistic? What does it represent? Tyler? Statistic. So 85% of okay? So 85% of 300 juniors, some might say 85% of the random sample, or some might just put 85%, okay? But the more you put, the more your reader is going to understand, okay? So 85% of 300 juniors went to bed after 11. Now, the parameter is literally not given. However, the wording is going to be the same, okay? So the percent of juniors who went to bed after 11. So the parameter is what we're trying to infer about the population. So the percent of juniors who went to bed after 11 p.m. If you notice, same wording. However, we were not given a numerical value. So this is inferring about what we want to know about the population. Okay? Let's try another one. Miss Betta wants to know if any students miss her during quarantine. She polls one of her classes and asks if they miss her, and 74% say they do. So, what is our population? Anna? or classes, depending on what. Okay. What would be our sample? Everett? Yeah. Okay. What else do we know? Tyler? Okay, good. So how would I formulate the parameter? Everett? Perfect. Okay. Again, very straightforward. The percent, sometimes you might be asked the average. You might be asked the proportion, okay? Whatever you have in the statistic should match what you have in what you write in the parameter, okay? All right, you guys are going to try number 2 on your own. Okay. So, tell me something. What do we know? Give me one thing. Mia. Good. Sample is 3 friends. What else? Rob. Go. Perfect. Okay. What else? Everett? And how much was it? They actually gave it to you. But did they give you an actual value? So you would, nope, that's still the parameter. In this case, in number 2, and I'm glad you brought that up, this does give it to you, okay? So your wording was absolutely correct. Now we're just going to include the average amount, the group, the friends, oops, consume per day is 43 ounces. Okay, you could include obviously water. How about the statistic? Kennedy? Okay, so here was kind of the first example that was given, like left-handed, right-handed. Yeah. For some cases, you're going to see both, right? So if you say just 43 ounces and 38 ounces, what are we talking about, right? However, for me and for you guys, I think some sort of explanation makes sense. Instead of just saying 43 ounces, what are you talking about? You know what I mean? Yeah. Hannah. So is the parameter like a total? Parameter, it can be a number value. It's talking about everybody in that group in this case. They're saying they recorded and learned. So in this case, they're looking at everybody in their group. They took that total and found out it was 43 ounces. Okay? The parameter is very difficult to pinpoint. They do not, most of the time, give you an actual percentage or result of it. Yeah, Luce? You could. You could. See, again, the wording here you said group, so you could say 38 ounces per day were consumed by the 3 friends or by the random sample. That could be added. Everything is very broad. It's not so much nitpicking about what's there, because even looking at different teachers or different books, whatever it is, if you put it side by side, I might elaborate a little bit more and someone else might just put 43 and 38. But what are you talking about? Like, what are you measuring? If they don't have this, what are you looking at? Right? So I think if you have some sort of explanation of what they're consuming or what you're talking about makes sense. It doesn't have to be this big 2-3 sentence situation. It's just you have to have some consistency. If you have 43 and 38, right, what does that mean? We need some sort of explanation. Okay? So when you get to some of these, you are going to see that go through and figure out the population, sample, and statistic. Do the parameter last and just take out, if it's not giving you a numerical value, take that out and replace it with percent, mean, average, whatever they're given to you. Okay? It can be, and people always struggle with the parameter. How much do I put? Do I put a lot? Do I mention a lot of information? Well, you're giving this to a reader, okay, to figure it out. Okay? So that leads to some issues that happen with sampling. Okay? We talk about the margin of error. Okay? A margin of error is the likely error that occurs from a sample regarding a population characteristic. So, what are some issues that can happen with sampling? Yeah, Everett? Correct. Correct. Good. What else? What else can happen with sampling? Yeah, Hannah. Okay. All right. What else? Yeah. Correct. Not answering, lying, not being truthful, having a small sample really is very difficult. Your errors are going to be probably off the charts. How many of you guys have been in homerooms or other classes where the Prob and Stat class has been surveying you? Some. Okay. So with that, the way the questions can be asked can be confusing, or people might lie or not be truthful with their answers, or not answer all the questions. So that sort of thing with sampling, and there was only like 3 or 4 of you. What was their goal? The whole population? Because 3 out of 4 out of 22, it's not great, right? But this was 3 out of 4. My other class, there was 15. So it's like, okay, who are you measuring, right? And, you know, you might not reach everybody, which is the problem with sampling as well. That's why the bigger the sample, the smaller the margin of error is going to be, okay? The margin of error is, we use this as a buffer, okay? So there's not going to be an exact percentage per se that represents the population, because that means it's definite, that it happens all the time at this percentage. So we use the margin of error, and the quick method that we use is plus or minus because of the square root. Also, we need a range of numbers. It's 1 over n, which is the sample size, okay? And like I keep mentioning, the larger the sample, the smaller the margin of error would be. The smaller the sample, the larger the margin of error would be, okay? So that's why we always want to have a large sample to reduce those errors from occurring, okay? So you guys might have heard on the news or any sort of possible articles that you've seen, we are 95% confident that blah, 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 blah. 95 is just a standard that we use. If you take higher level statistics classes, that confidence interval can change. But we keep it very straightforward. It's always going to be 95%. That we're very close to the true proportion. That's what it means. Okay? So anytime we're coming up with a confidence interval, it's our statistic that we received plus or minus our margin of error. Okay, so it gives you a range. It's a buffer to give a better idea of where people might fall depending on what you're looking at. Okay, yeah.
So for the larger sample size, it's smaller margin error, but like if you, for example, it's like 50 to 100 people, does it just make a big difference in amount of people that can lie or not?
When you do, and you're going to see an example in a second, how the margin of error changes based off the sample size. Okay, that still might be true. However, the margin of error will decrease a little bit with the sample size of 100 as opposed to 50. Okay, you're going to see it in 1 second. Obviously, we can't prevent any of that from happening, but they do this buffer to kind of give a range. Okay, so we have a research poll here. Of 35% of Americans got their most recent news from social media. Okay, the survey asked 2,070 adults in the U.S. questions about their media consumption. 95% confidence was given for this conclusion of this poll. So, Liam, what is the population? Okay. Let's see. Emily, what's our population? Emily Taylor. Our population is who we're measuring about. So it's not going to be a numerical value. Americans, or all adults. We could be even more specific. All American adults. Okay. What is the statistic? Tyler. Good. 35%. And the reason it's a statistic, it's because it's coming from a poll of that survey. Okay? That's why it's a statistic. What is the sample size? Everett? Good. Okay. So now we're going to figure out the margin of error. So you will need your calculator for this. So as a decimal, it's 1 over the square root of 2,078. Round to 3 places after the decimal. Okay, what did we get? Finn? Good. So this was 0.022. Now, as a percentage, what would it be? Go ahead, Everett. 2.2, to be exact. 2.2%. Okay, so now the confidence interval is our statistic plus or minus our margin of error. That is our interval. Okay, so when we make a conclusion, we are 95% confident the percent of Americans getting their news from social media is between what? How do we figure out that range? Go ahead. What was it? Be careful. Be careful. Yep. Yep. Good. Okay. So we have 30. What was it? 32.8. Thank you. And 37.2%. So what we did to get this, remember it's plus or minus. 35 minus 2.2 and 35 plus 2.2. So it gives you a range to buffer out any of those errors that might occur. Yeah, Rob? Okay, so we understand this part, right? Decimal, you just multiply that by 100. Okay? All right. So let's try another one. Yep.
To find the decimal, are you just finding the square root of 2000?
It's 1 over the square root of 2078.
So would you have to divide it first?
So, calculator, clear. 1 divided by second square root. Yep. 78. And enter. Okay. All right. So, a survey reported 16.8% of the population smoked with a margin of error of 3.2%. Okay? What is the actual range? Jamila? 13.6 to what? Yeah. To 20. Remember, actual range is 16.8% plus or minus the margin of error. Okay? So, the margin of error is always plus or minus, even though you don't see it. Okay? It's always plus or minus. So you take 16.8 minus 3.2, okay, to get 13.6%, and then you have 16.8 plus 3.2, which is 20%. Okay? Yes, Camille? That's the simple formula. That's the formula given. Okay. So you have 13.6 to 20% is the range. Now, what are some reasons why we have a range of values, not just a single percent? Ken? Okay. Yep. Okay, good. Yep. Perfect. And one solid number would be definite, right? That we did everything correct and that's true, right? There's no issues with our sampling, which is never the case. Okay? All right. So then here, this one, we are working backwards. Okay? A student gets a printout of PSAT diagnostic that say that there is 95% confident that she will score between 540 and 600 on the reading and writing section of the SATs. What is the estimate? So we have to find the statistic. How do we do that? Yeah. Excellent. Okay. So you take 540 plus 600, divide by 2. What do we get? Go ahead. 570. Excellent. So then, what is our margin of error? Yeah. In this case, it wouldn't be a percentage. It would be an actual just value. It's okay. That's all right. Emily? 30. How'd you get it? Good. Okay. So 30 plus or minus 30 because this was the range given to us already. So this is working backwards. We normally figure this out. Okay? So 540 to 600, we have to find the estimate. In order to find that, we take the average. 540 plus 600 divided by 2, we get 570. So that's our statistic. Okay? Then it says the margin of error. Well, if this is my statistic, how do I get to 540? How do I get to 600? Well, the margin of error must be plus or minus 30. Okay? So what would my interval look like? Luce? Perfect. So this is what the interval would look like, your estimate plus or minus margin of error. And then eventually, if we were doing a confidence statement, we would include that. Okay? So either one's fine. All right, let's try our last one here. We broke up participants. A poll broke up participants into two groups and asked both if they were bothered by seeing other people not recycle. Group A had 438 and Group B had 191 people that were surveyed. Okay? If 61% of both groups answered yes, so that means 61% in Group A answered yes and 61% in Group B answered yes. Okay? So we know the statistic for both is 61%, right? So now we have to find, in order to get to a confidence interval, we have to find what? Yeah. Excellent. So our sample for Group A is what? Emily? 438. So we have to do 1 over the square root of 438. And as a percentage. So what do we get? Tyler? Is that a hand? Okay. Emily? 4.8. So we have 4.8% is the margin of error. So the interval for Group A is 61% plus or minus 4.8%. Yes, Hannah. It's your statistic plus or minus your margin of error. Okay. So therefore, using Group A, we are 95% confident the true proportion, meaning the statistic, of Americans would be bothered by seeing other people not recycle is between what? So this is where you actually find the values. Stefan? God bless you. Good. 56.2%. It just froze. And 65.8. Good. Okay. I want you guys to do the same thing for Group B. Go ahead. The margin of error for Group B. Liam? Good. So it was 1 over square root of 191, okay, which gave you 7.2%. So what is my interval? Eva? Okay, so before that, 61% plus, it's okay, plus or minus 7.2. And Eva gave us our confidence statement. The true proportion of Americans would be bothered by seeing other people not recycle is between 53.8% and 68.2. Okay, so right here, you should notice the difference in the ranges, right? And in the margin of error. So if we had to choose which group was more useful, which one would you? Excellent. Okay, we would choose Group A because the margin of error is smaller and it's close to that true proportion of 61. Okay, the margin of error is smaller because of the larger sample size. Okay, do you guys have any questions? Okay, So the margin of error, one thing to keep in mind, larger sample, smaller margin of error. That's what we want. Okay? Pretty similar to the standard deviation as well. All right? So your practice and your homework that you could get started on now is the 4.3 practice in your pink packets, starting on page 10. So it's pages 10 through 12. Okay, pages 10 through 12. Now, you're going to notice number 9 and number 11 are the same questions, so do one of them, okay? If you choose to do both, great, but 9 and 11 are the same question. So, 4.3 practice, all. All right? Yep.